Today's lesson is an Algebra 2A lesson called Solving Systems of Linear Equations. Here's a message about communicating in the online environment. Now, there's no one else in this session today. We don't need to spend time on this slide. So here's your warm-up. The question is -3, 5 a solution to this system of linear equations? These are both equations of a line, and I'd like to know at this point, -3, 5 is on each line. These directions for setting up the audio are for a different system, so you could ignore that part. I'll give you a moment to check to see if this is a solution. So first, you're going to plug the x and y values of the point into each equation. If it works in each equation, then it's a solution to the system. It does work in both of the equations, so it means this point is on both the lines. Our lesson objectives for today are to determine whether an ordered pair is a solution to a system of linear equations, and also to solve systems of two equations with two variables by graphing, substitution, and/or linear combination. The lesson vocabulary for today is system of equations is when you have two equations on one graph. The solutions are the ordered pairs that must satisfy each equation in the system. And if all the equations in the system are linear, the system is a system of linear equations or a linear system. System of linear equations. A solution to a system of equations is an ordered pair that satisfy all of the equations in the system. A system of linear equations can have one solution. That's when the lines cross once. No solutions. That's when the lines are parallel and they never cross. And infinitely many solutions when the two equations are in fact the equation of the same line. Systems of linear equations. There are four ways to solve systems of linear equations. You can solve by graphing to see where they cross. You could solve by substitution by plugging the point into both equations. You can solve by addition, which is also called elimination, where you eliminate a variable, or you can solve by multiplication. When solving a system by graphing, you are finding ordered pairs that satisfy each of the equations. You would plot the ordered pairs and sketch the graph of both equations on the same axis. The coordinates of the point or points of intersection of the graphs are the solution or the solutions to the system of equations. These are the three types of scenarios you can have. The first one is called consistent, when you have two lines that cross at one point. There's one solution, the lines intersect. The next one is called inconsistent. That is where there are two parallel lines. There is no solution because the lines do not intersect ever. That's when two lines have the same slope, they're parallel. And the last one is dependent when they're the same line. That's an infinite number of solutions because the lines always cross. Here are three situations. You can see the first situation, the lines have different slopes. So they're gonna cross once. The second situation, when the x and the y coefficients are the same, then the slopes are the same, and they will never cross. And then this third situation, if you double every one of these terms, the first equation is exactly the second equation. They're the same exact line. Here's an example. What you can do with these two equations is you can take the first equation and get y by itself. So we're going to move the 2x over, and then we're going to change the sign of everything. So y equals 2x minus 2. In the second equation, we're going to also get y by itself. And then we're going to set the equations equal to each other, or graph them both. By getting y by itself, you can see the slope of this one is 2, and the y-intercept is negative 2. And the slope of the other equation is negative 1, and it has a y-intercept of negative 2. And if you plot them, you find the point 0, negative 2 is where they cross. This system has one solution. They have a different slope and a different intercept. Let's look at this situation. If you solve for y in each one, go ahead and do that. Solve for y in the first and the second equation. Since there's no one in the room and it's a recording, you can just, I'm going to go through this a little bit faster, but you can pause your video. These are the two equations when y is by itself. When you graph them, they are parallel because they have the same slope, which means that they have no solution. Same slope, different intercept, no solution. Okay, the same one with this one, you can pause it and get y by itself. When you get y by itself, you notice these are the same exact line, so they always cross. So there's an infinite number of solutions. There is somewhat of a shortened way to determine what type of system you're dealing with, whether there's one solution, no solutions, or infinitely many solutions within a system. So in these cases, we're not finding the solution. We're just going to say what type. So what you do is you write the equations in slope-intercept form, and then you look to see if the slopes and the intercepts are the same. To determine without graphing, once the equations are in slope-intercept form, that means y equals mx plus b, you can compare the slopes and the intercepts. It will have one solution if there are different slopes. It's okay if the intercepts are the same, that just means that that's where they cross. It will have no solutions if they have the same slope, but different y-intercepts. And it will have infinitely many solutions if the lines have the same slope and the same intercept. So let's determine this one without graphing. You're first going to get y by itself. So pause the video and do that, and then check your answers. Here are two equations that you get. They have the same slope and different y-intercepts, so that means they're never going to cross. The lines are parallel. Let's move on to the next one. Here's another method called substitution. You could solve one of the equations for one of the variables, and then whatever you get, you put into the other equation in place of that variable. So let's look at how this is done. Okay, so we're going to solve the following system of equations by substitution. Well, one nice thing is we already have y by itself in one of the equations. So we're going to take this x plus 3 and we're going to put it where the y is. So step 1 is already completed. We've solved for one of the variables in one of the equations. Step 2 is to substitute x plus 3 into the second equation. So instead of a y in the second equation, we're going to type in x plus 3. And then you're going to solve the equation for x. So x is negative 4. Step 3 is to substitute negative 4 into the first equation and solve it. So you get y equals negative 1. So the answer is negative 4, negative 1. Here's another one. Why don't you try solving this system using substitution? So pause the video, try solving using substitution, and then check your answers. I'm going to keep moving forward. So the solution you get is 1, 4. Let's try this one. So pause the video, pick which equation you want to solve for one of the variables. Find the easiest one to solve for, and then substitute it into the second equation. Solve it, get one of your variables, plug it back in to get the other one, and then you've got the spot where they cross. For some reason, this is not finished on here. So you would substitute it, you would get negative 12y plus 7 minus 2y equals 0. So you get negative 14y equals negative 7. And then you divide by negative 14, and you get that x equals 1/2. Then you would plug 1/2 into the other equation. So 1/2 of 4 is 2. And you would end up getting y equals 1. So your equation would be 1/2 comma 1. I'm sorry there isn't a slide for this. I'm not sure what happened to it. Here's the next. Oh, this is the same one. Is it? It is. Oh, it just continued. Okay. So when you substitute in 7 minus 3y, that's what you get. Oh, y equals 2. Whoops. I had that wrong when I said it. And then you plug a 2 in for y, and you get x equals 1. So it's 1, 2, not 1/2. Sorry about that. Now we have to check our system by substituting 1 and 2 back into each equation, and they both work. Okay, if you want to decide whether an ordered pair is a solution of a linear system, all that you have to do is substitute each point into each equation to see if it's a solution. So if you want to know if negative 4, 2 is a solution to this system, you plug it into each equation. You look on the left here, negative 4, 2 works in both equations, so it is a solution. That means negative 4, 2 is where these two lines cross. The other one, 3, negative 12, does not work in both equations. It works in the first one, which means that 3, negative 12 is a point on the first line, but it's not a point on the second line. Here's another example of the substitution method. First, we took the easier equation, the second one, and solved for y. Then we put x plus 3 in where y is in the first equation, and we solved for x to get x equals 1. Then you plug a 1 into the second equation, and you get a 4. Solving systems by graphing is probably easier than substitution, but you have to get y by itself in both equations and then graph them. So take a moment and look at this. You can pause the video. If you take each equation and get y by itself and then graph it, you'll see where they cross. So take a moment to do that with each one of these. There are 3 possible solutions to a system of linear equations in 2 variables that have been graphed. We went over this before, but I'm going to go over it again. One solution is where they cross once. No solution is where they are parallel and they have the same slope, but different y-intercepts. They will never cross. And the other one is if they have the same slope and the same y-intercept, that they are the same graph and they will have an infinite number of solutions. These graphs would be the same line. And the steps for substitution are given here, which we've already gone through. Here's another example of solving a system by substitution. Pause the video and look through and see what was done here to get the solution set of 2, -3. If you ever have any questions about any of these videos, you could just send me an email. Here's another example, but we have some fractions for coefficients. You can clear all of these fractions out by multiplying by a least common multiple of 2, 4, and 2, which is 4. So if you multiply 1/2 x by 4, you get 2x. If you multiply 1/4 y by 4, you get y. And if you multiply 1/2 by 4, you get 2. So you end up with 2x plus y equals 2. Then we have the other equation. So the first equation, we're going to solve for y, and then we're going to plug -2x plus 2 in for y. You get this resulting equation, -2x minus 10x plus 10. If you solve for x, you get x equals 1. And then you plug a -1. Then you plug a -1 back into one of the equations to get y. Then you should check them both in the second equation. So we have our solution set, -1, 4. So that's how you deal with one that has fractional coefficients. So you try this one. push pause, try this one, and then come back to the video. This shows you what to do if you have decimals and fractions. The first one you can multiply everything by 10, and the second one you can multiply everything by 35. So you end up with two equations with whole number coefficients. If you're solving a system of equations and you end up getting, you have the equations equal to each other and you end up getting 0 equals 0, then that means they're the same line and there's an infinite number of solutions. If you get something like 0 equals 7 or 5 equals 2, two numbers that don't equal to each other, then that means that they don't ever cross. So if we look at this one, these are inconsistent systems. How can you tell? Because the coefficients of x, the slopes, are the same, and they have different y-intercepts. But if you went to substitute and you set them equal to each other, and then you tried to solve it, you would get an answer of 5 equals -2. The x terms would drop out, which means there is no solution. Here are dependent systems. That means they're the same exact line. How can we tell? Well, if you solve one for x, and then you substitute, you get 6 equals 6, which is always true, which means they're the same line, so they have an infinite number of solutions. So if you don't notice that they have the same y-intercept and the same slopes because the numbers are different, when you go to substitute and solve, you'll end up with two numbers that are equal to each other when they're the same line. Here's our exit ticket. I would like you to pause the video and try this one. And then check your answer. The answer is 3, 5, or 3, 5. And there is an extension to the lesson. You can use this link here for a lesson extension. If you would like to watch a video on how to use elimination to solve instead of substitution, I've put a link in the chat box for you to some other videos. And lastly, the third link I'm putting up is how to solve a system of 3 variables, which you will be doing in Algebra 2B, but I just decided to put this up here for you anyway. So there's some additional resources for you. Thank you for joining the lesson today.